Problem number 10. What is the greatest possible area of a triangle with one side of length 7 and the other side of length 10? So we are asked about the greatest possible area. Now we can have different scenarios here. It says the side length is 7 and the other side length is 10. So we can have here the base is 10, side is 7. So that side could be like this, and that is 7. Or you can have like this. This is 10. This is 7. Or we can have a right triangle. This is 10. And this is 7. Now, which among these three triangles will give us the greatest possible area? Let us recall that in order to find the area of a triangle, we are going to use the formula area equals 1/2 times the base times the height. And in here, the base is 10, the base is 10, the base is 10. But the height is that line segment that is perpendicular or forms a 90-degree angle with the base. So the height here is this line segment. The height here also is this line segment. In the height here is this line segment. Now, which among these three scenarios will give us the longest possible height? Notice that if this side length is 7, then this height should be less than 7 because this is inclined. Also here, this height here should be less than 7, whereas the height here is exactly 7. So among these three different scenarios, it is this third option that maximizes the possible height that we are going to use for this formula. And therefore, using this now, we have area equals 1/2 times the base of 10 times the height of 7 gives us 10 times 7 is 70 divided by 2 is 35, which is this 35. Now, when you go to calculus, then it can be proven using derivative that it is indeed 35 that is the maximum possible area of this triangle. But for our purpose, let's just remember that in order for us to maximize the area of the triangle, we need to have the highest possible value for the base and the highest possible value for the height, and that happens when the triangle is a right triangle.